Okay. The homework, there's going to be quizzes and tests, and I'm working on creating the task because this is the first time this one's been done virtual. So, um, and then the other thing you want to do is go into assignments and click on this assignment, the photo ID, upload your photo ID. You click on it. This is what it looks like for you. I've already done it, but you can do it as many times until you get it right. But it'll normally just say start assignment up there. And then you can upload a file like a JPEG, PNG type file, image file. And if you can get it to do with the webcam, then by all means, do it. As long as it's clear and it's readable. So you can, but you got to make sure it's clear. So you can do it like that. But I've seen some really nice ones. I think the people that got the iPhones, they got a great camera in their phone, and that works. So you can do that. And then also, I've done it with Android for a site that's real picky about the, they want a real clear image. Took me several attempts to do it. But all right. So now, just any questions you got? Could be about this, the two, getting the My Math Lab set up or the assignment. Those are the two things want you to do first. And then at this time, I mean, this is why I recommend after every new material we go over, get into My Math Lab and do the work and bring questions to me, okay? Now, we'll have a chance to review when we get closer to the test. But just like this time here, I expect you to bring me the questions. Yeah, state ID, it can be the driver's license or Delgado. Yeah, should be able to. I think it was unlimited. Did you have a problem doing it? Yeah, that's fine. I know I got several of them. I just can't remember. Well, okay, that part is not important. The grade. Um, the questions that I put in there were questions where I wanted you to be able to know what you were going to be able to expect. Okay. In other words, I wanted to make sure you had a question so you could see where the calculator was at if you want to use that. Because you remember, um, you can't, it's going to be a lockdown browser, so you can't use anything on the screen on the computer. Let me go get some water. I gotta make my voice last all day. Yeah, but the grade on it is not, uh, not important. Okay, it's sort of one small thing, little thing, and um, but if you want to take it, yeah, go ahead, because that's the way it's going to be with all the quizzes and practice, which are generally practice things. This one is unusual in that it's the main reason is for it to, the main reason is for you to check that your browser's working. That's the main intent of it. Excuse me. All right, anything else? All right. Let me look at the student view. All right, and okay, I didn't have that on, but we're not going to be there too long. Like I said, I had an optimal setup because I've been working out of my home office for the last 18 months, and then get back over here and got to start from scratch. All right, so let's look at the next phase of our life in this applied algebra class. This is the course schedule. It's in the addendum down here on page 3 or 4, whatever it is. We looked at that. That was mainly reviewed. The only thing that wasn't reviewed was the completing the square. So that's a very important technique that you're going to need when we work with some of these things called conic sections, like circles and such. So that's the main thing. And the good thing about completing the square, you can use that to solve any quadratic. So if you only want to learn that method, that's it. You also remember we looked at the quadratic formula, which is technically reviewed because that's in 097. And then there was factoring, which is always a good one too. All right, so let's look at this. I'm going to try to keep this chat up because I want to be able to see if anybody's telling me anything. But it somehow wants to show on the screen. All right. So 1.6 is other types of equations. What's going on with that chat? I closed it. Why is it still there? Oh, because I had it open over there. I'm crazy as hell. All right, so these are different kinds of equations. We got technically a quadratic equation is polynomial, but there are other types. And remind me about 9:30 to take the roster, okay? I want to make sure, some people are late. And then there's radical equations. Those are ones we cover in Math 097. It's rational with rational exponents. Solve equations in quadratic form again. That means they're not exactly quadratic, but they're close. And you can kind of make them conform to that. And then there's absolute value equations. Those are kind of neat. They're pretty easy, I think. And then these are like applications. All right, now polynomial is the result of setting two polynomials equal to each other, okay? Polynomial equation. And then there's a general form if one side has 0 and the polynomial on the other side, and then generally you want those things in descending order in regard to the power. And you have to excuse me about my voice. I've been talking a lot more than I have. And start getting a little bit of laryngitis, which bothers me to have it this early in the semester, but thankfully I don't have to do anything. If you want to, you can go into the My Math Lab, but I'm going to give you some. And anything that I consider new, I'm willing to do them. And I'll find an equation from the text to do, like in the back of the text or in the My Math Lab. But if you want to open up your My Math Lab and do things, that's fine with me. That's what you meant. All right, so descending order. So here's a polynomial equation. See, it's got polynomial equation because it's got some terms that are equal to one another. And you notice that all the terms are different. There's no like terms. So what we're going to do is move everything on the other side. The left side is the way I like to think about it. And you notice what was just talking about descending order. X cubed, x squared, x, and then 0x, or x is x to the 0. All right. Now, this right here is called factor by grouping. Again, that was something that's covered in 097. I don't mind showing you factoring by grouping. So if you've got a question, let me know, because I'm just kind of assuming that you know what that is since 097. I know everybody doesn't retain everything. So I'm going to get on. I'm going to have my little board ready to go here. We looked at that. That was that completing the square we looked at last time. All right. So anyway, back to the lesson here. So that's the factoring by grouping. How do we know to use factoring by grouping? Well, when you have four terms, four distinct terms, in other words, none that can be simplified or put together. They're all going to be unique, as in cube, squared, x, and x to the 0. So four terms. So what you do is you're splitting it in half, like right here. On the left side, you factor out the greatest common factor of those two terms. There's nothing common between 2 and 3, so but they do have an x squared that you can factor out. And the way I know that is because there's x terms in both of those two, so I take the smallest one. And then x squared, x to the 2, and you can look at it two ways. You can say, well, divide this into that, and what's left? Well, you got 2x. Divide this into there, you got just a 3 because it's already got the x squared. You can also look at it as when you multiply these, do you get back to that? Now, we're bringing down this sign here, that negative sign. If that's a positive, you bring down the positive. Whatever that third term is, you bring down that sign right there. Now, again, we're looking at these two terms and seeing what's the greatest common factor. In this case, there's not an x in both terms. The only thing that's common to both is 4. It ends up being a negative 4 because of that sign. So then we find out what to put here. Negative 4 into negative 8x is 2x positive. Negative 4 divided into negative 12 is plus 3. Now, what you'll hopefully notice is, like I said, about this factoring by grouping, if you did everything correct, these two match. So instead of writing it twice, we're going to write it one time. So the one that repeats, we write one time, close it off with the parentheses, and then we're going to open up our parentheses and put that x squared in there, and down that negative 4. And that's factoring by grouping. And then once you've got it, then you go back to the same way you would do any other quadratic, and you just set each of those equal to 0 separately. This is the easy one because 2x plus 3 is equal to 0. We subtract 3 and then divide by 2. So negative 3/2 is our solution on that one. On the right side, we're going to use the square root property. If you wanted to, you could factor that as x minus 2, x plus 2. But the square root property is easiest here, I think. So put the 4 on the left-hand side, right-hand side, with the x squared on the left, and then take the square roots of both sides. The square root of x squared is x. Square root of 4 is plus or minus 4 square root. We put in that plus or minus at that point because there's going to be 2 solutions. If you just put plus 4, you're only going to get one of them. Okay? So then there's the solution, plus or minus 2. That's why with the coordinate formula, you got that plus or minus built in there. So then there's our solutions. You just got to remember that that's 2 and negative 2. So there's 3 solutions. And then they tell you to check it, but they don't show us, so we'll take their word for it. All right. A radical equation is one that's got a radical in it. In other words, that square root or cube root or any other type root. Again, this is something that we go over in 09 and 7, so I'll just briefly tell you about it. If you have questions, just shoot, okay? So radical equation just has a root in it. Now, what you do is you want to have a radical isolated on one side to do this. And then what you do to undo the radical, you do whatever the root is in the little crook, you're going to take that whole thing to that power. And then those two undo each other. So look at this. And then on the other side, you actually have some work to do. So watch what I'm talking about. All right. See, the radical is not isolated. So we're going to subtract 3. Now it's isolated. All right. We square both sides. The left side is easy. Because all the square does, and we've got x plus 3.
I'm trying to.
Over here, we're squaring this. Now, in Math 097, basically learn this form about how to do it without foiling, but you can foil it out at 0.2 because remember there, that's x minus 3 times x minus 3 into x squares. But remember how this shortcut works, where you square this and bring it down. You square the 3 down and put it there. Then you're going to use this sign right here, and you're going to multiply the 3 times the 2, which is 6, and tack on the x. That's how it works on the shortcut to the square. So now, on the left-hand side, you got that x plus 3 that came out of the radical. On the right-hand side, you got that the x squared minus 6x plus 9. So we're going to subtract x and subtract 3. So a negative x to that gives us negative 7x. And a negative 3 brings it 9 to 6. And then we solve that. In this case, it's factorable. So x minus 6 times x minus 3. So set each equal to 0, x is equal to 6, x is equal to 1. Now, these right here, it's really important to check them because you can, just because of the squaring property, and the reason is you could lose a solution. And why can you lose a solution? Because of the squaring of a negative value. In other words, remember we had a negative 3 on that right-hand side. And if you square a negative 3, you get positive 9. And if you square 3, you get positive 9. So it's possible to lose a solution. You won't always do it, but that's why they check them. So in this case, it comes out to a true statement. On the right-hand side, it does not. So the only solution is x equal to 6. So this is the general, this is also from Math 097. But basically, what this means is that if you have what they call a rational exponent in the numerator and denominator, you can write it as a radical, or you can take it as a radical and write it in this form. So the denominator is what goes in the crook. Okay, thanks. And then the m is the power inside. All right, this is a good time because, all right, I appreciate y'all telling me. Yeah, make sure I'm glad you reminded me because I probably would have just kept on going. All right, let's see. And I'm going to try to just do everybody's by reading their name. And then I'll only call out the people that I don't see. And you can see that I'm checking off your name too. The only problem is Zoom. I'll sort some by first name, and then the Canvas does it by last name. Oh, I got two people with the exact same name. Talia Martin. There's two of you out there. Put you on a phone and the computer. All right, I think I got everybody. Let me go through.
Cristia Rita Mancia on the top.
Part
1.
I'm going to call the ones now I don't see. Christy.
Here.
Here. I can hear it. I don't see what's going on.
Trinisha Brown, I'm here.
I don't know what I can do. Hold on a second. Headphones. Afraid if I do this, you won't have any. You won't be able to hear me. All right, what was it? I say So Christy Mancia here. I didn't see you on the list.
Yes, I'm here.
Okay. Tanisha Brown,
I'm here.
Lanisha Cloud here.
Here.
All right. Like I said, I'm just calling the ones I don't see.
Laisha, yeah, I'm here.
Harris, okay. Kayla Williams. All right, great job. That's only one person out here.
Your voice is low. I don't think it's real low.
Can you hear me better now?
Yeah, it's
Yeah,
better.
Okay. All right, just as long as this is working. This setup is a pain in it. All right, good. One problem is my voice is just cracking, and the other problem is just technical, but we got it fixed, looks like now. All right, all right. So, any questions so far? All right, now this right here is kind of a pain in the neck. All right, well, I'm going to do the best I can. Like I said, I'm not talking too much of a whisper because of my voice. So
I can hear you pretty clearly.
yeah, I mean, if you're not hearing me, restart the Zoom session. I don't know if those were old or what. Anyway, it might have been from a few minutes ago. But it looks like people are saying it. All right. So look at this, and we'll actually go through another one as well on the board because this is more or less new. All right. So what we got is 5x to the 3/2 power minus 25 is equal to 0. So what we're going to do is very similar to that square root property where you isolate, the radical on one side and I'm sorry, that the x on one side, the x squared on one side, and the number on this other side. Now, the only thing that's going to be different now, what you're going to do is you're going to take and undo this 3/2. And we're going to undo it by doing the reciprocal. The reciprocal of 3/2 is 2/3. All right. So what's going to happen? Remember, this thing is called the power rule. So you multiply these two. That's called the power rule. That comes from chapter 5 in Math 7. And that essentially just undoes that reciprocal. Because 3/2 times 2/3 is x to the first power, or just plain old x. Now, on this side, we're going to use this property that we talked about there. So we're going to take that 5 and put it inside of a radical. And then we're going to take the 2, the numerator, and put it as an exponent to that 5. And then we're going to take the crook and put the denominator in there. So we can square that out to 5 out to 25. But that right there, it's not a perfect cube. So that's the way it stays. All right. What I'm going to do, I'm going to find another one. I could probably go over to my math and have them do it when I'm just something a little bit easier. Because I don't think I could, let's see. I may just have to make one up, but because I can always go in the book. All right, so hold on. So any questions about that procedure on there? I want to look for another one and do it. Because like I said, whenever we go over something, you know, it's technically not review, I want to make sure we understand it. All right, just give me a minute. I should have had this already open, but I don't know what it is about working in my office. I can't get on the internet with the Wi-Fi for my laptop, and my hotspot doesn't work over there. But over here, it more or less flies. Uh, let's go over to the board. All right, I'm just gonna all the things coming up. I'm gonna make another one up. So 6x to the 3/4 minus, let's just say 36. I'm kind of making them up on the fly, so it may not be pretty, but that other one wasn't really pretty either. All right. So first thing, we want to isolate this thing over here. By adding the 36. So if you've forgotten about that kind of thing, that's what algebra is all about, keeping the equations balanced. And there was a 6 there. Now we want to have that x by itself. In other words, just x to whatever power. Otherwise, it would be messy. So we're going to divide both sides by 6. Again, this is used in the multiplication property of equality. As long as we do the same thing to both sides, we're all right. All right, so that's just going to be x to the 3/4. And then this is 36 divided by 6, which is 6. All right, now, remember, we're going back to this property up here in a second here. And then what we're going to use is our power rule. That's an x. Believe me, it's just a terrible x. As a matter of fact, I should erase it and make it better. So that's the x to the 3/4. Oops. I don't want that yet. So now we're going to take this to the power of the reciprocal. All right, and by the power rule, if you have one power or a base with a power raised to another power, you multiply those two things. In other words, x squared to the cube would be x to the 6. That's what we call the power rule. So that's what we're doing. But here, we're going to take it and we're going to raise it to its reciprocal power. And then that's going to let us undo it. We can also do the same thing over here. All right, this undoes. I'm going to come up here so that we've just got an X now. And just so you can show you what happened, what we're doing. See, that's 1. All right, so that's just X to the first power, or X. So that's why it's just X. And then it's 6 to the 4/3. And again, using this thing now, we're going to write it as a radical. I'm going to take the denominator of that fraction, put it in the crook, and then I'm going to take that 6 that's inside of the little house now and raise it to the numerator power. And that's going to be a big number in there, but doesn't matter. So what's 64? That's 36 times 6, I believe. 36 times 36. It's a big number. And unless you're asked to approximate it, you'd have to know what decimal place. You're just going to leave it as such. Okay. If you're using one of those calculators from like 097, that TIX2 thing or whatever it is, then you can do it with that. You can do the cube root thing. In other words, you can take 6 and raise it to the power. It'll also do a cube root, but that's not a perfect cube, so that's all we can do. If it was a perfect cube, you could write it as that number, but you leave it like that, and that's the exact value. All right, any questions about that type of equation? So how's that, Lanisha? Does that make it a little bit more understandable? This one had an extra step in it because what you have to do is always isolate the X. Well, what are you worried that you can wouldn't have work to show me? Because on some tests, they do ask us to upload your work. All right, for the regular in-class test, no, but usually for the midterm and the final, they'll ask you to take a picture of it and put it in. But I mean, with this, you're going to have do a certain amount of work no matter what, if you can figure out how to do it without doing it. But, well, yeah, that's what I try to stress in in math. Go with what's comfortable to you. I can show you how I would do it, but I can almost guarantee you, maybe if you took the class before, you learned another way, or maybe you figured it out another way. So yeah, there's no problem. I'm never going to judge your work as long as you, justify and get to something. And two, for problems where if you want to get part, if we have some where we're asked to turn in work, you know, you might get some partial credit if I was to look at it and say, oh well, they were off by just doing this little thing. But yeah, I never judge a work, but I have to admit sometimes I look at students' works, they don't understand how they get to it, but that doesn't mean that they haven't done it correctly. You don't ever have to have the same steps as somebody. That's how I can tell people they're cheating, is if they have the exact same steps to get to a problem. That's correct. Yep.
So is this called radicals with exponent? What is this?
It's
That's what it,
equations with rational exponents. And by rational, it just means that they're fractional exponents. All right, and I think this is probably the last one. Now there's one more little thing that's easy. This one is kind of tough, but not too badly tough. All right. So all right. If it's an equation, and when you've got the term sorted, and the most popular one like this is the fact that the first term would be like fourth power, and then the next one is x is the second power, and then the third one is just like in regular quadratic. It doesn't have a number. Now they show you here by way of substitution. Not everybody likes the substitution, and the substitution can be a pain in the neck, but it's easiest one to explain. All right. So what we're going to do is just play like this is a squared term. Usually what they do when you substitute, just use a different variable to remind you that you got to go back in a bit. All right. So x squared, I'm sorry, x to the fourth is really just x squared squared, right? Because you remember the power rule, 2 times 2 gives you 4. And then over here, if we just replace that with a u, we've got u squared. All right. So u is equal to x squared. So that means this one is just going to be a plain old u, and then this one is going to be u squared. So you can see now that it's a quadratic, and so we can go ahead and solve it, and that makes it easier to do it. Some people can factor them like this with no problem, and that's fine too. I'm just showing you the way that's visual, that it's easy to explain. So once you got it there, solve it by however way you want to. This is an easy one to factor. So this is u minus 2, u minus 3. Set each one of those equal to 0 and solve. You get u is equal to 2 and u is equal to 3, but you're not wanting to find out what u was. You were just using u as a temporary replacement. So now u is equal to x squared, so you replace the u with x squared, and then you use your square root property to find the two solutions. So now, this is actually called the fundamental theorem of algebra, I believe, that the highest power in a polynomial tells you how many solutions you're going to have. So there's 1, 2, because you got square root of 2, you got negative square root of 2, you got square root of 3, and negative square root of 3. So there's 4 solutions. Let me get another one here, and we'll do it on the board. you'll find us a good one. All right. Let me write it on the over here. And this is a little thing I do in my 097 class to show people why when you subtract a negative, you're actually adding, because when you go across zero, you're in bizarro world, essentially. Everything works just the opposite. All right, so I'm just going to write it out. You know what we're doing. I want to show you one more thing without having to rush. So I want to save a little bit of time. Oops, what did I do? I forgot to put the power 4 over there. I didn't fix that real quick. So as I said is, once it's sorted, it looks sort of like a quadratic. That's why they call it quadratic in form. So let's just say y is going to be equal to that. So if y is equal to that, and then we square both sides, that tells us what the other one is. So y squared is equal to x to the 4th. So we're going to use this one here. And I'm just using a different variable to kind of as a reminder that we're going to have to replace it back with this. That's what we're going to have to use. All right, so this factors pretty easily. Y'all know all these little tricks. If this is negative, the third term, then that means one's going to be positive and one's going to be negative. Since this is just a plain old y squared, you're going to have a y here and a y here. Now you need the factors of 3. Because this is negative, you need the factors of 3 that have a difference of 2. And that would be, there's only 2 factors of 3. There's 3 and 1. All right. So this right here tells you that the largest one has to be positive. So you put right there and right there. So just following the same old as far as factoring. Now we got to go back here. So we're going to take the square root of both sides. So x is equal to plus or minus 3 negative. There's a negative in here, so we're going to have to write an I. And then this is x is equal to plus or minus the square root of 1. So this is just 3 I square root of 3. So we got plus or negative I square root of 3. I square root of 3, there's the positive one, just to list them out. And then this is just negative 1, because the square root of 1 is 1. So there's your 4 solutions. Okay, questions? All right, let's look at that last type. I think you'll find these a lot easier. Than some of the last 2 new ones we looked at. All right, absolute value equations. Now, assume that you know by now that there are an absolute value, there's two things that can make it true. In other words, the absolute value signs eat negative signs, and they only spit out positive numbers. So therefore, the square root, I'm sorry, the absolute value of 2 is 2, and so also is the absolute value of negative 2 is 2.
Hello?
Mm-hmm.
What? I'm asking you, like, I'm telling you.
Is that question for me? I'm assuming not. It sounds like they was on the phone. All right, so here's the way we do it. We've got the absolute value of 2x minus 5 is equal to 6. All right. So what we're going to do is we're just going to make two equations based upon the fact that either a 5 or a negative 5 can be in there. So the 2x minus 1 can be equal to 5, or the 2x minus 1 is equal to negative 5. Either one of those would give us a 5. So solve this one, you get 2x equals 6 when you add the 1. Divide by 2, you got x equals 3. And then same thing here, just slightly different. It's got negative 2. And you can put it in here. Let's kind of just spot check it. 3 times 2 is 6. 6 minus 1 is 5. That makes it true. Negative 2 times 2 is negative 4. Minus 1 is also, that's negative 5. The absolute value of negative 5 is 5. Let me find one for us to work. All right, let's see. Back on the board. All right, so we got so it's an absolute, I'll tell you what. It's hard to make that line straight. All right. So now, same principle, we're going to make two equations. We're going to take this out. You dump your absolute value symbols. And on the other one, you're going to set it equal to negative 25. All right, so we're going to just solve now, just like normal solving. So negative 9. So here we're going to do the same thing. Divided by 2, negative. It's 32. So there's our two solutions. I'll leave them to you to check them. All right, so any questions about that? All right, so I'm gonna breeze through this little example, and if you got any questions, like I said, is it only one little page on it? All right, here's an application, and what an application is, is just applying it to some kind of a real world experience. And the thing is, um, things in real life are not necessarily as pretty and nice. So, but they've set this one up pretty close. So they tell us that h equals to negative 2/3 square root of I plus 67.6 models weekly television viewing time. All right. H is going to be the number of hours, and I stands for income in terms of thousands of dollars. Now they ask us what annual income corresponds to 33.1 hours per week watching TV. So what they're telling us is to replace this H with 33 minus 1, which is what we just take that whole equation right there, plus replace it with 33 minus 1. Now, what are we doing next? I'll show you on the calculator. All right? Because when people see decimals and stuff, they don't see the forest for the trees. So what we're going to do is subtract 67.6 to get it and move it over here so that this is just by itself. So 34.5 minus, and then it's positive on the right-hand side. So when we put it on the left-hand side, it's negative. Wait a minute, what did I do? I must have typed something wrong. So hold on a second. Oh, I'm sorry. I'm crazy. It's positive. And then we're going to subtract the 67. So it's negative 34.5. So this is an equation. So what are we going to do? Well, we're essentially going to use the square root property of what we did when we did that rational equation. So now we're going to divide both sides by negative 2.3. Over here, when we divide, that's just going to give us the I and the side of the square root. Watch over on this side. See, that's what's given us the positive 15. Now, on that square root equation we had, it was one of the first ones we looked at up there. To get that I out of the square root, you square it. So you square that, out comes the I, you square the 115. I'm sorry, the 15. And that's how you get the 225. So remember, the I means thousands of dollars. So that's $225,000 is the annual income of persons who watch 33.1 hours a week per TV. Now remember, this is just a model. It's not necessarily going to work for everybody, but that's a model. All right, so that's it for today. If you got questions, stick around. I got a little bit of time here. If you got some questions.
Bye. Thank you.
Okay, bye-bye. Yeah, it worked better than over there. Everything over there is slow. My PC's all right because it's hooked directly, but well, I'm gonna have to think about what to do, but hopefully in 3 weeks, maybe it'll be better over there. Because that's when they're gonna have it over there. And hopefully it'll be set up to where we have Wi-Fi in the offices. But we got to train all of them to be virtual in case, because if somebody we get exposed to COVID, we got to shut down, and go virtual. That's the plan. I didn't really think about that until Philip brought it up yesterday or Tuesday. Okay. You can go back and look at the video, but I got enough time to show you. It's easy as pie. Watch. It's the easiest thing you'll ever do. All right. Look at the screen. So go back to Canvas. You click on Course Materials. And I'll do it as a student because it looks different for me. Mine's already set up. All right. So you click on that course materials and you click launch courseware. And then here's where you got to watch out. I'm using the Chrome browser, so I know how to do it. But see, it's giving me this thing about pop-ups. So what you got to do is you go in Chrome. I don't know how to do it in any other browser. You have to look it up. You see that little red thing up there? That means it's blocking a pop-up. So I got to click on there and say, always allow, because it's going to block by default. That's how they protect you from getting spammed and all that. So now, when you click it, it pops open a new browser. First time, so you got to go through this. And nobody in their right mind is ever going to read that. You just read accept. Okay. Now, if you already have a MyMathLab account, you can go into it here. And this is especially important if you're repeating the class to use your old account so they don't, because yeah, I think it may not matter now that they're doing it like this, but anyway, it's a good idea to do that. And then if not, you do create, you fill all this out. At the bottom, you hit, once you fill it all out, this will turn blue down there, that little button. And then you create an account. But you got to fill all those things out.
Okay.
And then you'll go directly into the course that looks like this. And then from there on out, whenever you have this, let me leave student view. So from then on out, when you click on that, well, oh, that was the student one. That's right. So now when you do it, you're all synced up. And
Thank you.
And once you do that, from Canvas, you can always go in here and it goes directly to Canvas, or you can even go right to the MyMath site and go in with your account information. See, when you do it now, once you're synced, you go directly into the course like that. Okay?
Okay.
All right.
Thank you.
Welcome, Jennifer. I'll see you next week.
See you
Monday. Yeah, Tuesday.
Tuesday. I was gonna say I'll see you Tuesday.
I'm
Thank
glad
you.
it's, we're getting close to the end of the week here. Bye-bye. You got a question, Lauren?